Oh, I almost forgot to record. Okay. So real quick, derivative of e to the x is derivative of e to a function is e to the function times derivative of the function.
Is that a u?
Yes, because u is a function.
I thought it was just two i's.
Oh no, those are u's. Sorry.
Yeah,
e to the u times e to the u du
I thought it
dx.
was the prime.
Okay, so example 1, x squared times e to the negative x. So this is what type of? Exactly. So not only do I have a product, I also have an e to the negative x. So that means I need to use e to the u du dx. So dy dx, so derivative of y is 1 dy dx. Think back to implicit, right? Derivative of y is 1 dy dx. That's why we write this. Equals the first times derivative of the second. So it's always e to whatever times the derivative of the whatever. So it's the derivative of negative x. Perfect. Plus the second, which is e to the negative x, times derivative of the first. Derivative of x squared is, clean this all up. So negative 1 times x squared gives you negative x squared e to the negative x plus 2x e to the negative x. They have e to the negative x in common, right? So it could be brought out in front. And e to the negative x is really a negative exponent. So it could also drop down. The multiple choice answer would probably look like one of the last two. They wouldn't leave it like that. Good?
Ew. Bad. No.
Okay, just think back though. What's the u value? U is? What's the derivative of tangent?
C squared. So basically,
Exactly. So the rule is e to the u, so e to the tan x, times derivative of tan x, which is secant squared x. So really this is just secant squared x, e to the tan x.
oh my. The next one.
Is what type of rule?
I don't know.
It's a quotient.
See, even though I know what all that is, I'm gonna look at the problem.
So it's a hody hi minus howdy ho all over ho ho. So ho is the denominator. Times derivative of the numerator. So derivative of cosine is 2x is more than just x, so derivative of 2x is OD had minus pi cosine 2x. VHO, derivative of e to the 3x, is always e to the 3x times derivative of 3x, which is all over, oh well, which is e to the 3x squared. What do you do to a power to a power? Yeah, you would multiply. So it'd be 6x squared. Or, just kidding, 9x squared. No 6. Oh, I changed it to 9. Okay. To be honest, though, I'm not even going to square it. Why? Yeah.
Oh.
Because where's
yeah.
there 1?
That's a good point.
There's 1, and there's 1. So you could pull your e to the 3x out. What's that leave here? It leaves negative 2 sine 2x minus 3 cosine 2x all over e to the 3x squared. And like I said, we can say, oh, goodbye.
Do you have to pull it out more to cancel it out?
No, but sometimes, like, if I don't, like, we make mistakes trying to cancel things we can't cancel. So I do it just to, like, review that algebra aspect. Okay? So your final answer is negative 2 sine 2x minus 3 cosine 2x. These do not combine. They do not simplify. Like, you can't do anything with that all over.
It bothers me when that happens because they both have the 2x. So it's like I want to do something with them.
Yeah.
But you know what? Whatever, man.
And we're done. Okay? Example 4, e to the negative 3 over x. And it's a little more complicated. Use that idea of u and u prime off to the side. So, like, u, in this case, is negative 3 over x, which we know is negative 3x to the negative 1. So du dx, which could also be u prime, you can write it either way, is negative times a negative, so positive 3x, subtract 1 away to the negative 2, or 3x squared. Or 3 over x squared, sorry. So dy dx is e to the negative 3 over x times 3 over x squared. And I would rewrite it as 3 over x squared e to the positive 3 over x. I feel like the bell rings at 45. I don't know the schedule. Oh, yeah. So we will do your homework, go over your homework, everything, period, to whatever at the end of the day. I will see you.